in right back into notes into fundamental theorem of calculus. So happy Monday. Let's shake off the cobwebs. You guys ready to go? Give everybody in group a quick high five, a quick pat in the back. And Thomas, what's up, bud?
So if we take part of our test on Thursday, does that mean our review is due, or can we still ask you questions?
Review will be due all the way up until Friday. Yeah. I'm not going to be asking for the review early. Same as the practice test. Wait a minute. Usually the review is due the day early. Sorry, I forgot that this past semester we changed things up. The review is due attempted earlier, but we'll still be going over questions if we're not doing the test on Thursday. Does that make sense? Or like after school and all that jazz. Okay. Section 4.3, it was all about tying together the idea of area and Riemann sums and a definite integral. So number 12, it was as easy as, hey, it's the integral, the definite integral from 1 to 3 of, this is how you guys say it. Some of you are still learning how to read something like this. The definite integral from 1 to 3 of, like f of x, of 3 over x squared dx. Number 22 is just the definite integral from 0 to pi over 4 of tangent of x dx. Number 28, it was a rectangle, so it was as easy as base times height. So 6 times 5. Oh, sorry. 6 is the height, and then you have 6 and 4, so 10 is the base. He's alive. Chapel band. Thank you, bud. Okay, just keep an eye on the clock. No, it's okay. Check out the video. I have the evens right here. You can probably check in your group too, Michael. So final answer is 60. Number 32. They called it a trapezoid. Of course, you guys could have done a triangle plus a rectangle. It was up to you. Final answer should have been 15 if you had done the area correctly. 15. Number 34. Ooh, didn't we do that in notes? It's just a squared. That was one some of you guys might have had a question on, but I hope we answered it. Number 46. Number 46. They gave you clues, and so you were able to fill in. Hey, you were able to fill in based on the clues and the operations that you saw in the integrals, just kind of fill in facts. Like it was 10 plus negative 2, so just 8. Similar idea with negative 2 minus 10, plugging in the clues, negative 12, negative 4, and then 30. Hopefully that wasn't too bad, but we'll talk a little bit more about the clues today. Number 62, final answer was, if you had estimated with trapezoids, would have been 11.7296. But we know, hopefully, that we're always rounding to 3 decimal places, not sig figs, decimal places, tenths, hundredths, thousandths. So technically, you guys should have put 11.730. But actually on the AP, here's a weird thing. Let me start introducing you to now. They say 3 decimal places rounded 70 or truncated. And do you have any idea just what the English word truncated means? Like if you truncate something? Shorten, like cut it off. So actually, just looking at 3 decimal places. So like you can put if you want, they'll just look at the 3 that you need to have, and it needs to either be the 7.9, the exact without rounding, or the 730. The exact, well, you guys could have just plugged it into your calculator, 12.0000. Number 86 was all about greater thans or less thans. A was greater than. The left-hand approximation, it was an overestimate, and then B, the right-hand approximation, was an underestimate, would be less than. And then number 110, I think that's our, oh no, you got more. 110 was C. They did some basic anti-deriving, didn't they? But you could have also done triangles and constants with that one. And then number 112 was also C. The reason why they were able to do this without the fundamental theorem of calculus, if you guys notice, both 110 and 112, it looks like they solved the integral by hand. But the reason they were able to is because what we saw in our notes. Whenever you have, sorry, this is section 4.4. Let me go back a second. Oh no, you're not oriented right. I apologize. If you guys look at 110, for instance, what kind of function is an mx plus b? If you look at 110, you look at the integrand, it's just an mx plus b. What kind of function is that? Linear. And what did we talk about with linear functions? Technically, what can we solve all of those areas with? Well, if the shape has linear bounds, can't we just always use, geometry? Do you guys hear? You can always use geometry. So the reason why they solved 110 by hand is because it was like, oh, it's linear. So they just went ahead and made the geometry shape. They just didn't show the picture. Same thing with number 112. You can use geometry. Bless you, bless you. Whenever you have, oh no, that was trapezoids, sorry. This is where we're talking about geometry. This one you couldn't have done by hand yet without section 4.4, fundamental theorem of calculus. But anything linear, anything constant we can do with geometry, or anything that's a semicircle. Ooh, what's the equation of a semicircle again? Oh, I'm hearing lots of different things. What's the normal equation of a circle? No. The equation of a circle, like the actual graph. Oh. Nick's going back to the transform one. Patricia's saying r squared. What are we missing? Yeah. But let's assume it's at the origin, so it'd just be x squared plus y squared equals r squared. But remember, aren't we dealing with functions, so y is by itself? I'm going back to what I know you know better to try to get you to have the other form of it also as solid. If you get y by itself, you're going to end up having, if it's a, good, do you see it? So if you see one of these in an integral, you can also solve it because it will be a semicircle, which is weird. It's not a line. It's not a constant. It looks really weird, but there's also geometry. And then you guys are going to have to think about what AJ and you're solving the areas, then you're going to have to think of the area of a circle, and that's where your pi r squared comes in. Does that make sense? Okay, but wait, this is just a semicircle, right? So it'd be pi r squared divided by or times half or divided by 2. Oh dear, it's a nice marker though. Okay, coming back to our homework answers. So they did a little baby triangle here, and then they went ahead and did the base times height for the rectangle there. Sorry. And then number 112, I think they were doing trapezoids. Does that look right to what you guys were seeing? Yeah, I think they were trapezoids. So final answer is C. I know you guys already talked about the odds. Are there any odds that you guys in your groups weren't able to come to a consensus on, or any evens you need some further clarification on? 85. AJ, what page was homework on? 320 even? Oh, I heard the twa and I just filled it in with my brain. Do you guys ever do that? Like someone starts to say something, you're like, oh, I know what they're saying, and you get it totally wrong. Struggle. Jesus, make me a better listener. Okay, so number 85. I had a sermon the other day in church, wasn't it yesterday? About the difference between listening and hearing. That was a rough one. Do you guys ever do the whole like, and then you're, yeah, exactly, right? Thanks, Nick. Okay, on this one, AJ, we're actually going to kind of see some things today to help us with that. So let me take a picture of it so it's over here off to the side. But give me a second to go back into our notes for section 4.4, and then we'll come back to this question. That's a great question. Anything else besides 85? 101? Okay, let's go to that one first, and then I'll come back to 85. So number 10, nope. You guys had a long section of homework, like just pages. Ah, love it. Love it, love it, love it. If you guys do highlighting of important key problems that I tend to say are AP type problems, number 101 is that problem. However, the AP almost never words it like this. They give you this type of information, but they give it to you in a very different form. They give you this type of information, but they give it to you in a very different form. So go ahead, if I were you, grab out a highlighter. You might even want to go in the back of your homework spiral and make a point of this problem. We'll definitely see other ones like it as we get closer to the AP and as we start doing like practice AP exams, et cetera, et cetera. Before the AP, we also kind of do a topical review in CalcAB. We don't in BC. BC, we kind of just tackle lots of practice exams. But in CalcAB, we'll do a topical review starting at limits, seeing multiple choice and free response type questions with limits, and then moving to basic derivatives, harder derivatives, applications of derivatives, basic integrals, harder integrals, applications of integrals. So anyway, this isn't the only time you're going to see it this year, but if I were you, either go in the back of your homework spiral or make a point of it in your homework with a highlighter, etc., for the test number 1, but also most importantly for the AP. Let me show you how the AP would give this to you. Sorry, I don't want to start hacking in your faces. I need a cough drop. Okay, the AP would give it to you like this. They would make a table. Almost always. I can almost guarantee this. They would do x, and they would do f of x. And they would take these special x's, like 1 and 3 and 7 and 8, that are not equally spaced. I've made a big deal telling you guys about how, oh, this is when we're equally spacing it. This is when we're equally spacing it. This is when, but the AP doesn't necessarily do that. What do I mean? How much distance is in between 1 and 3? And then, not equally spaced, which means my bases are not the same. Now, this one was a little bit funny example because they gave you these special, oh, I didn't even put my 0, did I? They gave you these special x values, but then didn't they also give you these c values? I didn't even see the c's. My bad. Didn't they give you a lot more? If you guys remember when we were writing down k equals 1 to n f of, wow, it's a rough day. We put k in our forever card, but the other way of doing it is with an I. F of c sub I times delta x sub I, okay? This one is a little weird because in this one, it's actually giving you more information than the AP would. But what I want you to see is that actually all of these C's are just special X's. So if you were to put this in a table, you would have 0, 1, 2, 3, 5, 7, 8. They gave you so many different X values, but they don't actually expect you to do 1, 2, 3, 4, 5, 6, 7 different rectangles. Because if you notice, all of these x's only go up to 4, right? The c's go up to 4 and the x's go up to 4. So here's the weird thing. We could go ahead and come back to this function and we could find y values because we need, for our heights, remember, we need y values. And for our bases, we need to go in between x values. Long story short, in this problem, you're going to have 4 different rectangles. Oh, Jesus. We're growing in patience. Or at least we're trying, huh? 4 different rectangles. When we go to do the bases, if you guys look at this little baby formula, aren't bases found by delta x's? They actually, with the notation, are telling you which ones to use when. So for the first delta x, because of what I see, let me erase the circle because it's in my way. For the first rectangle, I need to go between 2 x values. And the first 2, x sub 0, x sub 1, in keeping with the notation, my first base is going to be 1. Not because it's the first hop, but because it's the first delta x. What's my second delta x? And then, so this is what you guys first saw when I only did the x values. Now that I've used the x values to get all my bases, I stop with those. I've done all my delta x's. They said, hey, these are the subintervals between 0 and 1, between 1 and 3, between 3 and 7, and between 7 and 8. But then they say, I don't want you to use the left, I don't want you to use the right, the middle, the trapezoidal. I want you to use whatever C's I tell you for the heights. I want you to use whatever C's I tell you for the heights. So, in the first subinterval, we're going to use the first C. So it's going to be f of 1. Why? Left, right, middle? No, because they told me to use it. Okay, fine. What's my f of for the second subinterval? 2. And then? I know, right? Don't follow these, follow the C's. 5. And then 8. The AP, when it gives you this information and has you do this kind of process, come on, screen, you can do it. It's some cable, and Mrs. Christensen's tried to fix it. I think it's the graphic card. When the AP does it, they're not quite as confusing and using different X's and different C's, but they are more and more testing that you know this limit definition of an integral. Now, this isn't, I don't have to go to infinity. I'm only doing 4. So I'm not taking a limit of this. This isn't an actual integral, but I'm still using the notation saying, oh, delta x's, you give me x's, fine. C's, fine. Now, how do I actually plug it in? Don't I need f of 1, f of 2, f of 5, f of 8? So we could have theoretically, for all the different values, we could have gone and found the y values by plugging into the function. But really, all we needed the y values at were the c's. So plugging in 1 squared plus 3 ends up being 4. We'll steal that in a second. Plugging in 2, 4 plus 6 is 10. Plugging in 5, 25 plus 15 is 40. Mental mathers. And then plugging in 8, 64 plus 24 is 88. If anybody wants to check me, that'd be great. As soon as we come over here, we can go ahead and say the approximate area. Which approximate area? I don't know. Whatever approximate area they just told me to find. Didn't say right, didn't say left, didn't say just Riemann sum, use this. Okay, fine. So f of 1 ends up being y value of 4 times 1 plus f of 2 ends up being 10 times 2. F of 5 was 40 times 4. And then f of 8 was 88 times 1. Stick it to the man. Haha. Or simplify it to make sure that you're right. But if this was a free response question, we would just leave it like that and be like, haha, got it done. Good question, AJ. That was an excellent one. Once again, this is harder than I've ever seen on an actual AP, but with them needing you or wanting you to know this notation of what goes in a summation to lead to the definite integral, who knows? They might ask you something like this. So delta x's go between the x's, and for the y's, use whatever c's they tell you. Is that cool? Okay, now let me go to number 85, but I'm going to actually get you guys back into your notes section 4.4, because what we were just ending with on Friday will help us on number 85. We were talking about what if they give you clues, and they actually gave you some clues in section 4.3. Maybe I should have introduced this earlier. I thought I was introducing it in the right spot, but it seems based on homework. I might have been a little bit off. So let me give you guys a second to go ahead and write down the examples. I need like 2 lines for each. Yeah, I forgot about the date story. Nicely done.
Mr. Jones? Oh my god, I love
It would be memorable.
it. Would start off somewhere and end up somewhere so weird that night.
All right. It was my fault. It was my fault. I distracted you all. But at least you're awake and you're talking and you're going to go into chapel being like, oh, who is it this year? All right. It's as easy as checking out the clue. It's as easy as checking out the clue and saying, oh, hey, sweet, let's plug in the 2 and let's plug in the negative 10, and your final answer is going to be 6 plus 10 is 16. Dun, 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 dun. That's the idea of number 85. They give you clues, you have to use them, but you have to use them rightly. And remember on Friday, if you got it down, there was a forever card of properties of integrals. If you're going from A to A, it's 0 because you haven't gone anywhere. You haven't gone 2-dimensionally anywhere. If your bounds are ever flipped, hey, if your bounds are ever flipped, look at the letter B. What's weird? Well, yeah. Lower to upper. 4 is not lower. 1's not upper. Number 1, you can take out the 2, but then you can also make it the way you need it to go. This is backwards, and backwards in motion, you have to think opposite and opposite sign. So to go forwards, 1 to 4, which is the proper way, and the way the clue goes. If the clue was 4 to 1, who cares? Plug it in. but it's not. It's 1 to 4. So we flip the bounds, but in flipping them and going backwards, we need to put an opposite. We need to put a negative, just like the property tells us. So then we can go ahead and say negative 2 times, plug in the clue, and the clue is 2. What's negative 2 times 2? Negative 4. So then letter C, why is it weird? What did they do at the very beginning of letter C? Good, added another clue. Why'd they add another clue? The bounds changed. So if these are signifying, my visual people, this will help. If this is signifying area, and if we're starting at x equals 1 and going to x equals 4, and there is this area in f of x that's being contained, then all of a sudden they say, no, 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 I don't want to go from 1 to 4. I want to go from 2 to 4. What do you need to take away from the larger area? What was in between 1 and 2, right? So if you're going from 1 to 4, and now you need to go from 2 to 4, you need to take away whatever area is in between 1 and 2. Oh, take away whatever area. Now let me show you the math. The math would say, okay, to get from 2 to 4, you can go from, let's see, 2. Deciding how I want to do this. Here we go. I can go from 1 to 2 of f of x dx plus from 2 to 4 of f of x dx, and it will be from 1 to 4. Can you guys find a property that says something to that effect? Is there a property that says something to that effect in the forever card that should be right above? To go from A to B, no. To go from A to B, you can go from A to C and to C to B. So to get from 1 to 4, I can go 1 to 2 plus 2 to 4. Does that make sense? And that'll be 1 to 4. So what do I plug in where? I don't know this one. I'm trying to find it, right? However, what do I know? That guy's negative 5, and that guy's 2. So whether you're a visual person, you're like, oh, that's the whole, that's the part, subtract the part from the whole to get the leftover. You could just, in your mind, say subtract whole minus part. Or you could type a little baby equation and say, oh, yeah, I want to solve for you. Subtract negative 5. So 2 minus negative 5 or 2 take away negative 5. Either way, you end up with the final answer of this being 7. Which is weird, I know, but true. Sadly, we can't subtract bounds. So we have to keep it all together as like a lump because of the meaning. So the meaning, we have to keep it all together as a definite integral area. What is area 2? Does that make sense? Good idea, though. Good idea. So let's peek at number 85 really fast. Do you guys see why I was having us finish the example in the notes first? Or examples? What have they given you in number 85 in homework? Clue, right? And what are they asking you to do? Evaluate. Now wait a minute, hold on. These are a little different than ours. How are they different? How are they different? What could we do for letter A? Couldn't we rewrite? Splitting up the f of x and the 2, is that a property, guys? So for letter A, let's go ahead and take them off to the side. So I could rewrite that, 0 to 5 f of x dx plus 0 to 5 of 2. What can I plug in for the first part? Yeah, I have a clue, so I can plug in 4 for the first part. What am I going to do for the second part? Wait, isn't that just a rectangle? So can't I just think about 1, 2, and then be like, oh, okay. height of 2 and a base of, so can't I just say 2 times 5 is 10? Does that make sense with geometry? So I can take my constant 2, I can take my base of 5. Now, hold on. Maybe some of you might visually also be able to think about this another way. What happened to the original function if it's plus 2 on the outside? The whole thing got shifted up 2. And if it got shifted up 2, what area just got included underneath whatever that funny shape was? A rectangle. So there are a couple different ways of looking at it. One way is, oh, everything got vertically shifted. Oh, hey, there's this extra like little box of 2 with a base of 5. So whether you look at the 2 separately and like, oh, it's a box, or whether you think about, oh, that whole, whatever that blop was with that area of 4, the blop just got shifted up and a little rectangle got included. So either way, we have to add that 2 times 5, that 10, to our original, what do we got? 4. So what's the final answer for letter A? 14. Letter B, what's different? All sorts of stuff. What happens if you add 2 on the inside, just graphically speaking? Shifted to the, now here's where it gets a little bit harder. But if you think about in letter B, whatever this blop was, and I don't even know what it was, but this blop was over here in between 0 to 5. That's where it was. And whatever the bloppy was, I don't even know what he is, it had an area of 4. What just happened to our block? It got shifted left 2. So what are the bounds now if what was between 0 and 5 got shifted left 2? Didn't 0 get shifted left 2? And didn't bounds? I'm just doing what the function tells me to with the transformation. So my whole little blop just got shifted over here, and I wish I could make it perfect. Program I would. There we go. So now I'm at 3 and negative 2, but the crazy, it's the exact same area. Just got shifted left 2. Now some of you might start to freak out around letter C or D, but actually they're even easier than A and B, because letter C says, hey, by the way, now this guy's even. What's going on if he's even? Not necessarily. Even in odd, symmetry. So if he's even, what's true about symmetry? Does it reflect over and down, or does it just reflect over? It doesn't reflect down because that wouldn't be a function, remember? X-axis symmetry doesn't actually appear in functions at all. Even. Think about a parabola. What kind of symmetry does he have? Across the y-axis. So take him across the y-axis. So if this guy now says, oh, hey, he's even, well, guess what? Whatever is also over, pretend that's the exact same thing. So what's my total area now? If it's going from negative 5 to positive 5. Well, if that was 4, what's that? So now I have 4 plus 4. But odd, what's different about odd and symmetries? Yeah. So instead it's going to be down here. Now we haven't talked a lot about this. However, as I finish drawing the picture, I have talked about moving right, moving left, positive displacement, negative displacement. Kiddos, what if how far you moved right is completely offset? Well, technically, in time, you're moving from left to right. So what if you move left and then you move right the exact same amount? What was your displacement? 0. This is going to negative change and a positive change. They cancel each other out. The overall area is 0. So number 85 did make it a little bit harder and a little bit more advanced, making you guys deal with symmetry and making you guys deal with geometry. But come on, that was section 4.3. Geometric, trapezoids, etc., etc. Ending in definite integrals, the ones that you can solve by geometry. But remember, section 4.4, doesn't have to do with geometry. Section 4.4 doesn't have to do with solving things by hand using graphs or clues necessarily, even though they might show up. Now, I know. Pause. You guys are all starting to write this down frantically. You don't have to memorize this page. This page actually just explains the why behind the what. So let's just skip here to the what. Let's skip here to the what, because to be honest, for homework, you don't need the why. I want to show you the why at some point with mean value theorem and how on earth an infinite addition of rectangles being squished and accumulated with one subtraction of two antiderivatives. But today is not that day. I will show you at some point, probably tomorrow. But today is not that day. This is forever number 34? Yeah, because properties was 33, right? Fundamental theorem of calculus. If a function f is continuous on a closed interval a to b, then the definite integral from a to b of the integrand f of x dx of a function is equal to, who's capital F? Well, look at the wording down below. The change in the who's capital F? Antiderivative. And what were you guys doing in section 4.1 and competing on? Antiderivatives. Plus c. If we're subtracting, though, he would have a plus c, and he would have a plus c, so we don't have to worry about the plus c's because they always would subtract and cancel out. So as you guys are writing this guy down, I do have an example right below. Oh, this is going to be a rough one. Okay, yeah, this homework isn't due until Wednesday. We need one more day. Nice thing is, no homework questions tomorrow. We can jump straight in, and we will. But the idea, because some of you can and should start homework because we know of antiderivatives. Here is how this is applied. To antiderive this function, hopefully, most of us know we have to rewrite. This is x to the 1.5, so x to the 3/2, but in a denominator. I am just rewriting. That's it, just rewriting. But now, to solve this definite integral by hand, without limits, without summation notations, c's, delta x's, just with the fundamental theorem of calculus, we can say, let's antiderive by adding 1. Has anybody added 1 to negative 3/2 yet? Plus 2 over 2? Negative 1/2. And then remember, we divide by that value, or we multiply by the reciprocal. 2 over 1 times 1 over 2 would cancel out and reduce. You could do a plus c, but both plus c's will cancel. We plug in the bounds, 1 to 4. I changed the definite integral because it has been integrated. The definite integral is gone. A bracket is at the end, just getting me set 4. It's time to plug in the top bound 4. Then it's time to plug in the bottom bound 1. But for my purposes, you guys know me. I like to rewrite to make things easier on, do you love yourself? On your brain. So I'm going to put the negative 1/2 in the bottom. And here's how you finish your definite integral. You plug in the top bound, 1 minus, and then you plug in the bottom bound. You guys saw me doing it a couple times when I was showing you a peek behind the curtain. We end up with negative 2 over 2 is negative 1 minus negative 2 over 1 minus a plus. If you were to throw this definite integral into your calculator, it's not a geometric shape. It has a curve, which means it'd be impossible for us to solve by hand with geometry without using a limit and crazy summation-y stuff. But the awesome thing of the fundamental theorem of calculus is that you antiderive, you plug in the top bound, plug in the bottom bound, one big subtraction, and you are there, even better than your calculator. Get out of here, cool kids. Start homework tonight. Not due until Wednesday. I'll make changes on Google Classroom if I need to. I think everyone ended up making it in today, right? Anyone absent? Michael came in late because of worship. Yeah.